Continuation of 9.6, and we are on example number 5. Find the area of the region that lies inside the circle, r equals 3 sine theta, and outside the cardioid, r equals 1 plus sine theta. So the first thing we need to do is find the point of intersection, or points of intersection, okay? So we need to find the intersections. So we're going to set our 3 sine theta equal to our 1 plus sine theta. And if I subtract sine theta from both sides, I get 2 sine theta is equal to 1. Divide by 2 on both sides, sine theta equals 1/2. So I need to find for what theta is my sine 1/2. That happens in the first and second quadrants. And that would be at pi over 6 and at 5 pi over 6, okay? And so we know then that if we integrate from pi over 6 to 5 pi over 6, that's going to include my area. So my area is going to be, I'm going to pull my 1/2 out in front. And now for this one, since we are talking about inside, because we're talking about this area right here. We're talking about inside the circle, but outside the cardioid. So you can kind of see that this is at pi over 6. This one is at 5 pi over 6. And remember what I said, if you took a random little sliver there, you are going to have the sliver along the cardioid, right? And you're going to have the sliver along the circle, okay? So you're basically going to take the 1/2 r squared d theta of the circle and subtract the 1/2 r squared d theta of the cardioid, okay? Because, you know, if you take the circle, you're going to get this whole thing. That's going to give you all of that for the 1/2 r squared of this 3 sine theta, because that's your circle. But then when you subtract the 1/2 r squared of this cardioid, you're left with, we'll do purple. You're left with what you're looking for, this. And so we're going to do that all the way along here. I just did like a little representative, you know, sliver, okay, just to show you that when we do the integration, it's going to give us all of these, right? It's going to give us all those slivers, and we're going to add them up. All right. So I'm going to go back to red. And so we said that we're going to do the 3 sine theta squared minus the 1 plus sine theta squared d theta, okay? That's going to be how we get what's left there. So this is going to be 1/2 integral from pi over 6 to 5 pi over 6, 9 sine squared theta minus, and then this is going to be, I'm going to go ahead and put this in parentheses because it's a binomial. I get 1 times 1, and then I get a 1 sine theta, and another 1 sine theta gives me 2 sine theta. And then sine theta times sine theta gives me sine squared theta. I do need to distribute this negative to all of these terms. And when I distribute this negative to the sine squared term, I'm going to have a total of 8 sine squared theta minus 2 sine theta minus 1. And so I have simplified that. And now I'm going to substitute my sine squared with 1 minus cosine 2 theta. So I have a extra page here just for this. So this is going to be example number 5 continued. So I'm going to just split it up. 1/2 minus cosine 2 theta divided by 2. So that's the equivalency for sine squared. So this is going to be 4 minus 4 cosine 2 theta minus 2 sine theta minus 1. And the 4 and the negative 1 can be added together. They're like terms, giving us 3 minus 4 cosine 2 theta minus 2 sine theta d theta. And so now we can go ahead and integrate. So we've got 3 theta. Now remember, the derivative of 2 theta is 2, so we'll be taking that negative 4 and dividing it by 2. So that's going to give us negative 2, and then this will be sine 2 theta. And then I get a negative sign for my derivative when it is a positive cosine. Okay. And now we'll use our fundamental theorem of calculus. 3 times 5 pi over 6. The 3 and the 6 will reduce to 2 in the denominator, so 5 pi over 2. Minus 2. This will be times the sine of 5 pi over 3. Plus 2 times the cosine of 5 pi over 6. So that's my evaluation at 5 pi over 6 minus, this is going to be pi over 2, minus 2 times the sine of pi over 3 plus 2 times the cosine of pi over 6. Close the bracket. So now I'm just going to do some little triangles here. Our 5 pi over 3 is like 1, 2, 3, 4, 5. We're in the 4th quadrant. 60-degree reference angle. Sine is negative square root of 3 over 2. Plus 2. Cosine of 5 pi over 6. Here's 6 pi over 6, right? So 5 pi over 6, that's a 30-degree reference angle, 1, negative square root of 3, 2. And cosine is negative square root of 3 over 2. Now minus pi over 2, I'm distributing the negative here, plus 2. My sine of pi over 3 is sine of 60 degrees, square root of 3 over 2. And then distribute my negative, minus 2, and my cosine of pi over 6 would be square root of 3 over 2. Lots of square root of 3's over 2. So this is plus root 3 minus root 3 minus pi over 2 plus root 3 minus root 3. Interesting. And so I've got 1/2 times, this would end up being 4 pi over 2. And 4 pi over 2 is 2 pi. So the 2's cancel, and I get pi unit squared. That is the area that is inside the circle, outside the cardioid, okay? All right, so I'm just going to erase these little triangles that I used so they don't get in the way for our other 2 examples. Example number 6. I'm going to do it in a different color so that you can, let's do green. Find the area of the region that lies inside r equals 3 sine theta and outside r equals 2 minus sine theta. Okay, so inside that perfect circle, outside that dimpled limacon or whatever that's called. So inside this, but outside this would be this right here. So we do need these 2 points of intersection here. So we're going to set 3 sine theta equal to 2 minus sine theta. And if I add sine theta to both sides and divide by 4, I'm looking for where the sine is positive 1/2, and it is at pi over 6 and 5 pi over 6 again. And remember how I'll just do it in red, how I took and I said, imagine that it was like one of these things, and it would be the 3 sine theta, because that's this outside function. It would be that integral, 1/2 r squared d theta, minus the 2 minus sine theta. Because when you subtract off that 2 minus sine theta, I don't even know what color to use. How about blue? If we subtract off this part, the blue part, you're left with what we're looking for. And we're basically just going to go that, and add them all up, okay? So that's our plan. So we're going to say that the area is, and I'm going to bring the 1/2 out. This is going to be the integral from pi over 6 to 5 pi over 6, and it's going to be our 3 sine theta squared minus our 2 minus sine theta squared d theta. And so 1/2 integral pi over 6 to 5 pi over 6, 9 sine squared theta minus, I'm going to put a bracket, 4 minus 4 sine theta plus sine squared theta d theta. Sine squared theta minus 4 plus 4 sine theta minus sine squared theta d theta. And if I add my like terms, I get 8 sine squared theta plus 4 sine theta minus 4 d theta. And I'm going to put my equivalency in again for sine squared. I don't know if I have any room left on that. Not really. I should probably add another page. Oops. Oh, let's get rid of that. Okay, so I'm going to bring this down all the way to here. This is going to be example 6 continued. So this is 1/2 integral pi over 6 to 5 pi over 6. And I'm going to put I've got 8 times, and then we're going to put our equivalency 1/2 minus cosine 2 theta over 2. And then, was it plus? I'm gonna write this, but go up and make sure. Plus 4 sine theta minus 4. Plus 4 sine theta minus 4. Yep. Okay. So this is 4 minus 4 cosine 2 theta plus 4 sine theta minus 4 d theta. And so the 4 and the negative 4 go away. And now we can integrate. So negative 4 divided by 2 is negative 2 sine 2 theta. And if I take the derivative, I get positive sine. It must have been a negative cosine. Okay. Oops. So now let's go ahead and put those values in. Negative 2 times the sine of, this would end up being 5 pi over 3. Minus 4 times the cosine of 5 pi over 6. That's your first one, minus, now put your second one in, negative 2, times the sine of pi over 3, minus 4 times the cosine of pi over 6. And 5 pi over 3 was in the 4th quadrant, and the sine would have been negative square root of 3 over 2. And then cosine of 5 pi over 6 is in the 2nd quadrant, and it would have been square root of 3 over 2. Negative, sorry. I'm going to go ahead and distribute that, so I get positive 2. Oops. I just want to calculate my sine. I don't want to write it again. The sine of pi over 3, square root of 3 over 2. And then distribute that negative. I get positive 4. Cosine of pi over 6 is square root of 3 over 2. So this is a positive square root of 3, positive 2 root 3, positive root 3, positive 2 root 3. So 2, 4, 5, 6 root 3 times 1/2 is 3 root 3. and that would be units squared. And so that is the area inside the circle and outside the dimpled limacon, or whatever it's called. Okay, that was our example number 6. These examples take a lot of room. Okay, example number 7. Find the common area of r equals 4 sine theta and r equals 2. Okay, so they actually are the same thing, only one is centered at the origin. The other one is centered on the point 0.02. But the common area, and I'm going to change my color again, I guess orange, I don't know. The common area is this. And they are, though, the same circle because they are the circle that has a radius of 2. So basically, they both have a radius of 2. The point of intersection, you're going to set 4 sine theta equal to 2. So our sine theta is 1/2. Every single example. So you can see that this would be a pi over 6, 5 pi over 6. Now, I don't know if you noticed, but did you notice that on these, when we did that, we didn't have to worry about this sliver that wasn't counted because it didn't need to be counted. We weren't talking about anything until up here. And I didn't notice the same thing here. We didn't have to worry about the sliver, you know, because it's like if I wanted this part right here, I wouldn't have been able to get all of it by taking just pi over 6 to 5 pi over 6. It skips this, okay? It skips that part. It all